If we want to create a bar graph, but look at two variables at the same time, we can go to Graphs, and instead of going to Chart Builder, we can go to Legacy Dialogues and Bar Graph, and then choose the clustered one. And this chart is going to allow us to look at two different variables in the same graph instead of separately in different graphs. So click Define. And then, for example, say we want to look at the adherence to treatment in our x-axis. We're going to put that over there. But we want to look at the adherence to treatment separated by treatment group, and we want to see these side by side in the same graph. Then we will define the clusters by treatment group. So this is the variable that we're going to separate by. And then if you look here, bars represent, it's already on number of cases. Oftentimes the number of cases doesn't really tell us much, and I would say more than not, we want to look at the percent of cases. So we're going to click that, and we're going to click OK. And then it's going to give us, in one graph, the adherence to treatment. In the conventional treatment group is blue, and the new treatment group is green. And on this side, we have the percent. So we can look and compare and see if the adherence to treatment is different by the treatment group. And that's what we want to do. And this is, I think, much better looking at all in one graph instead of doing it separately and then trying to compare them. Okay, we're going to go over the answers for practice 2, which we did in our second practical class. I'm not going to read through it because it's going to be way too long, but we're going to look at exercise 1 and we're going to fill in this table. Whenever we want to describe data, we oftentimes use a table and do a graphical representation. So in exercise 1, we're filling in the table. When a variable is categorical, we need to provide the percentage or proportion, and when a variable is quantitative, we need to put the mean and standard deviation if the distribution is normal. But if the distribution is not normal, we need to provide the median and the interquartile range. So oftentimes we put the standard deviation and the interquartile range in parentheses after the mean or median. Okay, so I'm just going to do this quickly and not show you how to do every single one, just a few. So we need to provide the total number for all, and then we need to separate by treatment group. So we're going to do the total for each variable first, and then we're going to separate. So to find the proportion for a categorical variable like sex, we're going to choose sex. And we're going to choose, it's already going to display the frequency table. We can actually do all the categorical variables together. So we're going to do tobacco with that. And we're going to click OK. And this gives us the frequency in percent here of sex and of tobacco consumption. So you can add those to the table. As you can see, they are here. And then we're going to find that for the quantitative variables. So go to descriptive statistics, frequencies. We're going to reset this, and those two are age, which is a normal distribution, and level of dental plaque at the beginning of the study, which is a non-normal distribution. So to get different statistics, we want mean for the normal distribution, we want quartiles, we want median, we want standard deviation. Continue. We don't want to display frequency tables because they're not categorical variables. Okay. So we have age here, and we have level of dental plaque. For age, we want to take the mean, which is 49.55, and we want to take the standard deviation, which is 8.766. And then for dental plaque, we want to take the median, which is 16.55, and the interquartile range, so you will write this 14.32 and 22.9, since the interquartile range is the 25 and the 75 percentile. Okay, and now we want to split this by treatment group. So we will go to split file, compare groups, treatment group. Okay, and then if we go back to frequencies, now we are getting these statistics for the quantitative variables split by treatment group. So this is the conventional treatment group, and this is the new treatment group. So in these columns where it says new treatment and conventional treatment, you will put these statistics. And then we can do the same for the categorical variables. Go back to frequencies, we can reset, and we can choose tobacco consumption and sex, and display frequency tables, okay. And then we have tobacco consumption by treatment group and sex by treatment group. So that is how we can fill in the whole table. And then exercise 2 asks, using the table, compare the individuals assigned to the different treatment groups. Are any of the variables very different? Should they be? If they were very different, what could it be attributed to? So I've written the mean age and standard deviation are similar amongst the two treatment groups, which tells us that the dispersion of the data is similar. Median dental plaque between the two treatment groups is a bit different. The new treatment groups starting with less dental plaque than the conventional treatment group. The data is more dispersed in the conventional treatment group. The conventional treatment group has a greater proportion of males and a smaller proportion of females than the new treatment group. The new treatment group has a greater proportion of smokers. These statistics should not have big differences. The differences could be due to random error or non-probabilistic sampling. This means that when we're doing a randomized controlled trial, we want the two treatment groups to have very, very similar characteristics. So when we look at these and they don't have similar characteristics, that can cause alarm, and that could mean that maybe these individuals were not put in each treatment group at random, and that could be a problem. Okay, the next one is to create graphs. So we want to do them for the variables tobacco and dental plaque. Tobacco is a categorical variable, so we should use bar charts, and dental plaque is a quantitative variable, so we should use a box plot. To do that, let's do tobacco. We are going to go to graphs, legacy dialogues, bar, and clustered, and this will allow us to get the treatment groups together with the variable tobacco. Define, we want to use tobacco consumption as the axis. We want to define the clusters by treatment group. And we want the percent. The N doesn't really tell us much. The percent is oftentimes more important. So click OK. All right, this gives us a graph of tobacco consumption for the conventional treatment group, and then tobacco consumption for the new treatment group. Okay, we can get graphs for the variable dental plaque. So let's go to Chart Builder. This is just another way to do graphs. You can do them either way. We want to do a box plot, so drag that over. And we want to do level of dental plaque, and we want to do it by treatment group. Click OK. So this is splitting the two graphs, and that's because we had split the file. So if you want to get two separate graphs, you can use split file, and it will give you them separately. But if we want to put them together, then we can unsplit the file. We can go back to charts, click OK, and now we have it together. So we have the box plot of level of dental plaque at the beginning of the study by the conventional group, and the same for the new treatment group. So you can put those in there. Okay, exercise 4 says describe the state of the participants at the end of the study. Create the necessary graphs. So this is dental plaque, adherence to treatment, and complications. And I have the answers down here. Okay, so you're going to do the same thing that we did for exercise 1 to fill in the table. So dental plaque is a non-parametric or non-normal distribution, so you need to put the median and the interquartile range. And adherence to treatment and complications are categorical variables, so put the proportion or the percent. This is the percent. I'm not going to do that because it's the same as before. Make sure that you're using the correct dental plaque variable, and that's dental plaque at the end of the study. And then you can do the same for the graphs. And then exercise 5 asks you to compare the individuals from the table and the graphs here. And you can see what I wrote. And then exercise 6 wants you to just enter the information that you've already put in the exercises above. So put the dental plaque before the study in the conventional treatment group, the dental plaque before the study in the new treatment group, then use the variable dental plaque after the study, put it in for each treatment group. Then you're going to subtract. You're going to subtract this number minus this number. And you get this, negative 2.9. And then do the same for the new treatment group, and you get negative 5.2. And then this is the relative difference. So you're going to divide. You're going to take the post divided by pre. And this number shows you the proportion of dental plaque that the individuals have at the end of the study. So in the conventional treatment group, they still have 84% of the plaque that they had when they started out. But in the new treatment group, they only have 67.3% of the plaque that they had when they started the treatment. So then it asks you to analyze, and you can see what I wrote. And that is how you complete this practice.